Hello students, welcome to the next video of Unit 5 subject Data Science. In this video, we are going to cover about the data structures and data transformations with R programming language. Let's take a brief recap about the previous video. In previous video, we have discussed about the conditional executions of R programming language where we discuss about the conditional statements like if else, nested if else, and switch case. After that, we have discussed about the loops where we can discuss three types of loop: for loop, repeat loop, and while loop. And lastly, we have also discussed about the functions where we can discuss user defined functions, how we can create a user defined functions, how we access them, how can we call them with the varieties of function with respect to their arguments. In this video, we are going to cover basically data structures along with the data transformations related functions. Let's start with the data structures. Although we already discussed some of the data structures previously, but we tried to explore more in this video. So basically data structures is the tool that is used to hold the type of value, how the values are stored. So basically it is a structure that stores, that holds multiple values. It is basically made up of different data types available. So data types define what kind of data is held in a value. So according to our programming language, the common data structures that are used in this language are vectors, list, array, matrix, data frames, and factors. Let's start with the R vector. Vector is a basic data structure which plays an important role in R programming. Basically, it is a sequence of element which shares the same data types known as the vector. Vector can supports logical type, integer type, doubles, character, complex, and raw data types. The elements which are contained in the vectors is called components of the vector. The element which is stored in vector is known as component of that particular vector. So vector length is basically the number of elements presents in the vector is called vector length. It can be calculated or find out by the length function. We can use a length function and able to identify the total length of vector. So vector can be classified further into two types: atomic vectors and list vectors. So atomic vectors means all the elements of same types, but in list the elements are of different data types. How to create our vector? Simple, we can use a vector function c to create a vector. Here we demonstrate we have created number vector, a variable, and we pass three values, and number vector is displayed. So the results is displayed like 10.1, 10.2, 33.2 as it is. We also can assign vector value according to the colon operator using colon operator. In this example, we have shown with this. In this z variable, the value is stored in a sequential manner, means starting from 1 to 5. So here is the result of this: 1, 2, 3, 4, and 5. Lastly, sequence function also can be used to get the value into vectors. So here we create a sequence vector and we call a sequence function starting from 1 to 4 and differentiate each value by zero point 0.5 and display the sequence value, and result was 1.0, 1.5, 2.0 means interval of zero point 0.5. All the sequences are stored in this vector. Next is atomic vector. So there are four types of atomic vectors. Atomic vectors plays an important role in data science. Atomic vectors created with the help of vector function known as C functions, and these atomic vectors are integer vector, character vector, logical vector, numerical vector. So we are going to discuss each and every one by one. So let's start with the numeric vector. The decimal values are known as numeric data types in our programming language. So here is the simple program with to demonstrate the numeric vector. We have created a vector variable d that store a value 45.5. Then we create another number vector variable with c function where we already put a value mentioned accordingly. Here we display d and number vector both along with to check which type of this variable contains a value. For this we use a class function just to find out the types of vector, and you must be surprised that without the C function 45.5 is directly assigned to D with the numeric value. So by default this value is numeric, but here also we create the numeric value. So this type of data is called numeric vector. Now next is integer vector. A non-fractional numeric value is called integer vector. This is represented by the integer. So here the integer size is 2 byte, but long integer can be of a 4 byte as per the R programming language. So here we demonstrated this via simple program. We write we create a variable d and assign it a 5, and we need to typecast this value into an integer. That's why we use as dot integer. It means the value is converted or typecast into integer. Directly we can use this by using L character to indicate that it is a integer value, or we can directly convert the value as dot integer by the simple normal C function. Another way to use this is we can provide L character with the all numeric values. We also check here class of D, E, and integer vector and integer vector 1. These are the four types to store integer values, and the results are all the classes, all the methods that we use in this program are going to store integer type of value. Next is character vector. A character is held as 1 byte integer in a memory. For example, we have assigned Shubham to a variable d, then Arpita to e, and we also create a f that converts the numerical value into the character value using as dot character typecasting. We also create a character vector 1 that store continuous character strings like Shubham, Arpita, Nishka, and Vaishali. And we are going to print D followed by E, F, and character vector 1. These are the four variables, the four different methods that we use to store it. And we also display the classes of each and every variable. So let's look the results. First, we print the value of D. D is printed as a Shubham, but we have initialized it with single quote. Second one is Arpita, that is initialized as a double quote. Third one is 1, 2, 3, 4, 5. These are the numeric values, but it transfer it in a character. So here 1, 2, 3, 4 is character value instead of its normal numeric value or integer value. And whatever we store in the character value in form of double quotes in form of a string is as it is in, entered into character vector, and all the types of these four variables are character type. So this is what how we deal with the character vector. Next is logical vector. Basically, logical data types are having only two values, either positive, negative, or true or false, or in numerical terms we call them 1 and 0. These values are based on the condition is satisfied or not. A vector which contains Boolean value is known as the logical vector. So let's discuss with the program. So here we entered three different values as an integer and three variables d, e and f, and g variable we are going to compare whether d is greater than e. D means 5 and e means 6. So whatever the result is, maybe either form of true or false is stored in G. Similarly, H, E is less than F. So whatever the answer is stored in H, and then we display the values we'll see in the output window. And again we create a vector known as log vector with the combination of all such conditional values like d is less than e, d is less than f, e is less than d, like so on. And we will check what the value is stored in the log vector, and finally we display the value of log vector. And at last we print classes of these variables. And let's have a look. So d is greater than e means 5 is greater than 6, so result is false. We have stored false in G because we display G. Similarly, for H, E is less than F, that is true, and true is stored in a H, and here true is displayed. In this scenario, the set of true and false is stored in log vector, and log vector is displayed. And all the these vectors gh and log vector having a same logical vector class, they belongs to logical vector class. Now let's discuss about the applications of the vectors. So vectors are basically used in machine learning for principal component analysis. Then it also used as input which are provided to the deep learning models, and in the form of vectors. Vectors are also used in deep learning model. These are the basic applications where the vectors are used. In the development of support vector machine algorithms, also vectors are used. Vector operations are utilized in neural network also for the related various operations like image recognition and text processing. So these are the common applications where vectors are used. So vectors are widely used in the analysis process. Let's come with the next data structure, that is R list. So it is a second type of vectors that contains different types of data element with different types of numbers, vectors, strings and others. Means kind of hybrid vector that contains with different data types of elements. It also contains a number, it contains a character, it all contains string related to that in a single list, single variable. That is the important. It can also contains a functions or a matrix as its elements. So a list is data structure which is component of mixed data type. Just take an example. Here we created a vector with integer values, normal numerical values. Then we create a character vector. Then we create a logical value vector, and then we combine this list. We are going to create a list with the list function, where vector means this is included, character vector included, logical vector is also included, and this is the result of our list. We have first vector, that is 3 4 5 6, then Shubham, Nishka, Gunjan, Sumit, that is character vector, and finally logical vector, true, false, false, true is still there. So this is a single data type that's combine different data types. So this is a list. Now how list is created, how we can create a list. So there is a simple program to create a list. We create a list one that contains three value 1 2 and 3, that is a numeric. In list 2 we store Shubham, Arpita and Vaishali, three character names. Then list 3 we include a list of 1 2 3. Remember, this is numeric and this is using C vector function. In list 4 we use a boolean value, and finally we display the list with different types. So this is the our list. In first list the value is 1 2 3. They are taken as three different elements of list. Similarly, in list 2 we take three different name as different element of a list. But in list 3 when we use a C function, so this 1 2 3 can be treated as a single list element. In list 4 true, false and true is as it is inserted. We show second program. Here we combine a list data using the list function, where we can store two characters names. Then C function, using C function we insert five numerical value, two boolean values and one fractional value, one integer value, and we print this hybrid list. The results are like Shubham and Arpita can be treated as a two different elements of this list. The C function, using C function when we store a five numbers 1 to 5, that are stored as a single element. Boolean can be treated as a individual single elements, and numeric plus integer, all the types are included in a list. So इन दिस प्रोग्राम हमने देखा कि जितनी वैरायटी के डेटा टाइप्स हमने लिए वो सारे के सारे एक डेटा लिस्ट में बन गए. सो दिस इज द बेसिक बेनिफिट ऑफ लिस्ट. वी कैन include different types of data types in a single list data structure. How next is accessing list elements. So basically R provides two ways through which we can access the element of list. First one is through the indexing, and second one is the naming access. For the naming access we must have the named list mapped with that list. On the basis of that we can use the second one. Otherwise the first one, that is based on the indexing, is the default methods. So let's have a look with accessing element using index. So here is the program. Here we create a list that contains a vector, matrix and a list. So list data, here is a list function we use. We have taken input of Shubham and Arpita, Nishka, then matrix of 2 by 3 and list BCA, MCA, BTech, these are the courses. Then we are going to print the list data 1, and next we are going to print the list data index 3. Have a look with the results. When we talk about the print list data 1 means first element of this. So first element is stored using the C function, means this Shubham, Arpita and Nishka will be treated as a single element for the list. Hence, we have displayed a single element. Then in second way, we are going to use data of 3. So data of third element is BCA, MCA, BTech, because this was the third element. So what is the second element? Second element was this matrix that is not shown here. So in this way, using the index, we can use the list. Now, how we can access element using the names? For this, we also take the same example as a list data. Now, here we create a names of list data. Here name is students, marks and course. So Shubham, Arpita, Nishank is a student. These matrix is treated can be as a marks, and BCA, MCA and BTech is treated as courses. And here we are going to display with their names. We are going to first print the student followed by the marks. Let's have a look with the data. So when we talk about the students, it display the students. Then we display the marks. Then it is display the marks. Now we discuss how we can manipulate the list elements. So for this program, we use the previous list. We allocate the names of the elements, that is students, marks and course, as just like a previous program. Now here we are going to add a element at the top of the list. Currently we have a 3 elements in this list, and we are going to add Muradabad in the fourth position, or as a fourth element of this list. And when we going to display this fourth element, it shows Muradabad. If we want to remove this, then we can just assign it list data index 4 element is null. Now fourth element is Muradabad and it is replaced by null. Now when we display this fourth element again, it displays null because now Muradabad is replaced with the null value. Next, if we want to update any elements of this list, how we can do this? So in third element of list, we have BCA, MCA and BTech. But we are going to update it here as list data index 3 means element third. We have right master of computer applications, and we are going to third element of the list. So the third element of list, that is course, is master of computer application. But where is BCA, MCA and BTech? Those values are replaced with the new value because it's update. So instead of BCA, MCA, BTech, masters of computer applications is presented in their place. So in this way we can manipulate element of the list. Now let's discuss about how we convert a list into vector. To see this, let's have a look with this program. Here we create a list 1 with the sequence of 1 to 5, and then we create a list 2 with sequence 10 to 14. We convert this into vector using a function unlist. Vector 1 contains unlist element of list 1 and v2 contains unlist element of list 2. Then we print both the vectors v1 and v2 and add them and print the results. Let's take our results. So this one is the list 1 this one is list 2. When we convert these lists into vectors, this is the vector 1, this is vector 2 v1 v2, and this one is the sum of this vector. The execution of this is 11, 13, 15, 17 and 19, mean the additions of vectors. Next, arrays and matrices. We already discussed arrays and matrices in one of our previous video entitled as Data Science Unit 5, Input Output Arrays and Matrices. So we are not going to cover in this video. So for these two topics, please refer previous video. So let's continue with the next data structures, that is our data frame. A data frame is a basically two-dimensional array-like structure or table which contains a column values of one variable and rows contains one set of values for each column. So basically data frame is a special case of list which each component has a equal length. Here are some characteristics related to data frames. The column's name should be non-empty, means column name cannot be a blank. The row names should be unique. The row names, that is the value of rows, should be unique. Naming of the rows should be unique. No duplication is allowed. The data which is stored in the data frame can be a vector, numeric or character. Each column contains the same number of data items. So these are the basic characteristics of the R data frames. So just take an example with the how to create a R data frames by using a program. To create a data frame, we use a function data dot frame that is used to provide you the facility to create data frames. Here I create a employee ID that contains sequence from 1 to 5. Employee name, we have a 5 names. Then salary, we also have the 5 numeric values, that is 5 salary values. We also create a starting date. As date, we are going to convert the date from the string values. Date will discussed in next video. The details of dates, how we can work on dates, will discuss on next video. So here we provide a value of dates also, and at last we are using a special function that is string as factors, that is used when we are going to deal with the data frames. So it indicates the string as factors value as a false. So printing the data frame is just like that. When we print this employee data frame, then it will looks like this. This is our row numbers, nothing else. These are the row numbers. So employee ID 1 to 5 we have stored, so there is 1 to 5 employee ID value. The name of employee Shubham, Arpita, Nishka, Gunjan, Sumit, and their respective salaries along with the starting date that are the mentioned. So this type of representation is provided by the data frames, that is much more useful when we do analysis of data. Now extracting data from the data frames, we can extract the data from data frames, our data frames, in three ways, or we can say that we have three methods. First one is we can extract the specific column data from a data frame using the column name. Then we can extract the specific rows from the data, then extract the specific rows corresponding to the specific column. So first we discuss about the extracting the specific columns from a data frames. Here we create a data frames with employee ID, then we have the 5 names, 5 salaries and date, previous programs that we already discussed. And now we are going to extract specific columns from a data frame. So here we create a variable final that provides data frame employee data with respect to employee ID and employee salary. So I just want to extract only two things. First is employee ID and second one is employee salary from employee data, that is the name of the uh, data frame, and we store it in another vector final, and this final is going to be displayed. So this final is also a data frame, not a vector. Here we use a data frame, so another data frame, a data from a data frame to another data frame. And here we have only the employee IDs and salary, the names are missing, so we are going to access column wise data. Then next is uh, specific rows from a data frame. Now how we can extract data from rows specific. So this is the same code that we used to create a data frame. Now to extract row we are using, we create a final, and here we provide data frame name employee.data row 1 column null, means first row all values. Then we want to check the last two rows, then we use final, the sequencing 4 to 5, means 4 entries and fifth entries. So we skip second and third entry. As a result, the result of this single row is this: employee number 1 Shubham, their salary, starting date. Similarly, last two entries 4 and 5, employee ID 4 and 5 is Gunjan and Sumit with the respective details. So this way we are going to fetch the data based on the row. Next is extracting specific rows corresponding to specific column. So for this we also use the same code as example, and here we extracting second and third row corresponding to the first and fourth column. So here we create a final, we use name of data frame, that is employee.data. Instead of row value we use a vector that contains 2 and 3, and instead of column value we use another vector that contains column number 1 and 4. So one is employee ID and fourth one is your starting date. Then we print the final, and here we find that employee ID of second and third row with the respective of only two values, employee ID and starting date, instead of all the available data. So here we discussed about the three things: how we can extract data column wise, how can we data extract data with row wise, and how can we data with the respective rows and column wise. So next is R factors. Basically factors is the data structure which is used for the field which takes only predefined finite number of values. Basically this is nothing but the limited number of different values. These are the data objects that are used to categorize the data, like on the basis of male, female, or means on the basis of genders or some specific labels. Factors have labels which are associated with the unique integers stored in it. It contains predefined set values known as labels. By default are always labels are in alphabetical order. They means they are shorted as alphabetical order. So let's discuss about the attributes of a factors. So we have a six attributes of a factor shown in figure. X, labels, exclude, orders, and max. And so X, basically X, it is the input vector which is to be transformed into a factor. So here we are also starting the transformations with respect to data. Labels. So it is an input vector that represents the set of unique value which are taken by X. Then labels. So it is a character vector which corresponds to the number of labels. Exclude, used to specify the value which we want to be excluded. Ordered, it is a logical attribute which determines if the labels are ordered or not. And max, it is used to specify the upper bound for the maximum number of labels. So let's take a program with example how we can access components of factor. So here we create a vector with the character names. We don't know how many names are there, but we have a set of names, approx 30 names. Then applying the factor function, we apply the factor functions to create their factors. So for factor data, we apply factor function to data vector that we created here. Then printing all elements of records. Now we want to the print factor data, what is the value of factor data. Then we print fourth element of factor data, then fifth and seventh. Then we exclude the fourth position and display all the data. And we also can use accessing of logical vector. We can access element through the logical vector. Let's see the results. So this is our value that we display. Then these are the labels. Then we are going to display the fourth element. So fourth element is this one. So this one, but labels are still 4 because we have stored 4 unique names. So labels is 4 different. Similarly, we display fifth and 7. So here we found fifth and 7. Labels are same. Respectively, we excluded the fourth value and still we have answer. So this way we find out the output from the factors. Now factors in data frames, how we can apply factors in data frames. So here we are going to create a data frame with the height, weight and gender. To create a data frame, we use data frame function and provide these 3 vectors in a list. And when we display this, the whole data can be displayed like this. Then we apply the testing if the gender column is a factor. So print is factor input underscore data, that is the value of name of data frames, then according to gender. So whether this is gender specific, answer is yes. Then we are printing the gender column to see the labels, how many labels we have. We print input data as genders. So we have a gender like male, male, female, female, male, female, male. So this is displayed the value, and this is the labels. We have only 2 labels, that is female and male. Why female come first? Just because of alphabetical order arrangements. Next is data transformations. To data transformations means we can transform data as per the requirements of the analysis. So here we put a simple program that demonstrate the data transformations. Here we create a vector object with the city. In city we can store four cities: Bhopal, Lucknow, Patna and Mumbai. And state, we can put their respective states with the third vector, that is zip code. Although we use pin code, but we also put the pin code value in a zip code. Then we can combine this into a data frame. So we create addresses and combine them using the function cbind, where city, state and zip codes is found. Then we print header. So first data frame is printed, and in first data frame we print the addresses value. Then we create another new data frame using new addresses with the function data frames, and we also stores the similar type of values here, and then we also print it as a header second data frames, and we print the second data frames that is newly created. Then we combine data frame 1 and data frame 2 together to merge them. So we create a new all dot addresses. Then we also use another function known as rbind, just to match both the data frames, merge both the data frames, that is addresses and new addresses, and create a new header, that is the combined data frames, and we display this merge data frames. Let's have a look of with the output. So this was my first data frame with the header first data frame. Here city, state and zip code is available, this. Then next data frame that we created and displayed is Raipur, Ranchi with its state, CG, UK with respective zip code. In third phase we merged with the rbind and we display the results. So this is the combined results of both data frames. So basically rbinds is append the data frames, second data frames into first data frames. So here we have a four values, and here we have two values, and after merging we have total six values. Now some transformations functions that are majorly used to transform the data. Filter is used just to pick up the observation samples based on the values. Distinct is used to eliminate duplicate rows. Arrange is used to reorder the rows. Select is used to find out the column variables by their names. Rename is used to rename the columns. Mutate and transmutate is used to add and create new variables. And summaries to compute statistical summaries like the means, sum, average, median, etc. So these are the basic some transformations functions that are used in data transformations. So in this video we have discussed about the data structures and basic data transformations. Thank you for the watching video.